The history of agriculture is as old as our civilization. It was agriculture that allowed human beings to settle down from hunter gatherers to dwellers. The dwelling into colonies with help of agriculture helped human beings to think and spend more time in cultural and scientific development, which in turn allowed progression of technology and advancement of civilization. For any civilization to grow and flourish, food security is of paramount importance, and it brings us to our topic, agriculture. Agriculture plays a vital role in the economic growth of any country. With the increase of population, frequent changes in climatic conditions, and limited resources, it is becoming a challenging task to fulfill the food requirement of the present population. It is estimated that the population of the world will grow past 10 billion post 2050. Rapid urbanization and requirement for housing will reduce the available land for agriculture or will put tremendous pressure on forest lands. Coupled with climate change and geopolitical pressure, agricultural crops and patterns have seen immense change in the recent past. Wars and government interventions has raised the vulnerability of agricultural supply chain as we have seen during the present Russia-Ukraine wars. The input of agriculture, like pesticides, insecticides, have raised the salinity of soils, and hence control of such elements is required to safeguard the interest of all stakeholders in this planet. The answer to all these questions lies in precision farming, and precision farming combined with the power of data, computers, and cutting edge hardware with IoT will transform the landscape completely. Precision farming is one of the most patented technologies, surpassing fintech and medical devices. As many as 9,000 patents have been filed for the last 15 years in the domain, and it goes to show the emerging importance of the field. This specifically holds true for an agrarian economy like India, which aims to double farmer income by 2025 and have immense pressure to secure its environment and food security. Before we start our discussion, we need to understand the various phases of agriculture. Generally, agriculture starts from selection of crop to land preparation, selection of seeds, and controlling inputs like water and pesticides. While yield is important on many inputs, technology helps us to reduce the variability in harvest and usage of data in post-harvest agri-supply chain. Hence, we see the usage of data becoming ubiquitous in every aspect of agricultural supply chain. From an architecture point of view, in the sensing layer, various inputs of soil chemistry to weather condition plays an important role. In the processing layer, we see various aspects of cloud computation, proprietary algorithms, and usage of IoT in defining the decision layer. The decision layer consists of prime mover and implements to give precise inputs for homogeneous output. In the application layer, we see wide usage of technology in maintaining the harvest health, storage, and transfer of produced. Almost every form of advanced machine learning algorithms like supervised, unsupervised, and reinforced learning are used with some elements of biomimicry. Many advanced algorithms like computer vision and neural networks are used in precision farming. We would discuss the usage of such algorithms in detail at the various stages of crop cycle production. The most critical part of agriculture is the soil, and understanding its chemistry helps us in deciphering what crops will be successful. Most macro and micronutrients are used and tracked using a spectrometer and combined with many algorithms like random forest, support vector machines, decision trees, and artificial neural networks help us in determining the quality of the soil. The graph is an excerpt of various machine learning algorithms and their relative accuracies in understanding the soil chemistry. Another major aspect of agriculture is in the prediction of the crop yield accurately and precisely. It helps in reducing variability and also plays a major role in crop insurance and managing peak harvest season. From a project we did for a crop finance company, the basic flow of information and how the outcomes are determined are shown in the graphic. Combined with traditional knowledge of agriculture and applying data sciences, the decision becomes easier and yield specificity can be determined pretty accurately. While we see variability in geographical distribution of crops, machine learning algorithms can predict the accuracy with very low errors as we see in the table. In this case, we see multiple regressions play a very accurate means of predicting and creating a baseline for these actuarial calculations. The most important aspect of precision farming is the speed control of prime movers, which is the tractor, and attachments in the agriculture. The hardware attached to the tractor plays a critical role here. In the table, we find widespread usage of hardware required to precisely control the data sets required for agriculture. We find the usage of many advanced communication protocols like Bluetooth, LoRa, Wide Area Network. The various inputs for these devices are mapped back into telemetry device and central hardware, which is fed back to the engine and the vehicle control unit. The feedback mechanism is closed looped into the device, which helps the machine learning algorithms to provide real-time accurate data to the prime movers and its implements. In the case study, by making a smart implement like sprayer responsive via IoT, the farmers were able to reduce the inputs like fertilizers and hormones by 65%, which results in millions of rupees in savings for the customer. Another critical aspect of farming is weed detection and disease detection. And we find the usage of advanced libraries like image processing and computer vision. The weeds can be classified into two parts, inter-row weed and interplant weed. While inter-row weed is easier to detect, interplant weed requires high degree of sophistication. Our general data flow happens by scanning the image of the plant by high resolution camera, which is transformed into a binary image and stored in the hardware. The binary image is compared in real time with the data set of existing weed by color segmentation and edge detection. If the match percentage exceeds a certain threshold, the hardware sends a command to the engine control unit of the tractor to attack the weed very precisely. It is a highly precise operation and reduces wastage, which can never be eliminated by manual applications. Using NLP, the farmers can also trigger actions in the hardware via voice commands and image sequencing to provide very accurate and desired results. Harvesting is the only value-adding exercise in the entire farming process. The current day harvesting has many issues. Not only the windows of harvesting is very limited, but also very specific. Due to the pressure to reap the harvest, there is acute shortage of manual helpers during that time. Also, the harvesting makes a lot of wastage. It is estimated that nearly 20% of the crops are damaged or wasted during harvest, and it is imperative to use technology and data to maximize the output. In a regular harvesting process, imaging is done by drones, and with computer vision, the areas ready for harvest are finalized by algorithms like k-means clustering, and while it provides 80% accuracy. The table provides an approximation of the output. Also, with the advent of IoT, we are seeing artificial neural networks take a center stage. Every harvest has a specific grade or color, weight, and a fructose value. Also, the harvesting regions show swarm intelligence. As a result, predicting early harvest can be done with hardwares and algorithms. The current day machine learning algorithms like convolution neural networks and multi-layer perceptron can predict the harvest accuracy by 95%. The data is fed back to the prime mover, which helps in accurate harvesting. Survivor analysis helps in determining the life of the harvest, and after which the harvest loses an economic value. Control of storage temperature and humidity with the help of survival analysis helps in understanding the life of the product and thus allows farmer to make decisions regarding when to shift and where to shift the produce. The graphic shows the logical case study of a mango and an apple farm in two different districts in India and its onset of decay using survival analysis. It also helps in controlling parameters like storage condition, which in turns increases the life and the crop and increases the earnings for the farmers. Emerging machine algorithms like blockchain is used to track and trace the quality of harvest at every point of life cycle. At every part of supply chain which is validated, and eventually after a successful validation every blockchain is validated. It helps in tracing the sources and origins of high value crops like cashew, coffee and mangoes. Concluding, we see that the summary of machine learning algorithms used in agri supply chain. As we see, the data is becoming more and more ubiquitous in every aspect of value chain. By controlling the inputs, the precision farming is not only increasing yield but also is helping us and build a sustainable and a climate resistant earth as well.